Okay, now we're going to work on problem number 18, which is very similar to problem 17. It's another relative velocity problem. In this case, we have Anita. She's still moving 5 meters per second to the right. We have a ball thrown toward her from the left and a ball thrown toward her from the right. Now, what I've written up here is Anita, that's what the little a means. Anita says she sees the ball approaching her at 15 meters per second, both of them. Toward her. So the question is, what was the ball, what is the friend who threw ball 1 see as the velocity of ball 1? Let's see, how did they word it exactly? According to her friends, with what speed was ball 1 thrown, and according to her friends, with what speed was ball 2 thrown. Okay, so again, let's look at this. If ball 1 was moving at 5 meters per second toward her, and she's moving at 5 meters per second, it would be as though there's no relative motion at all. She would see the ball not approaching her or moving away from her, like the two of them are on a truck moving down the road at 5 meters per second together. So in order for her to see any velocity, that velocity she sees is really a delta. It's got to be greater than the 5, or she won't even see it at all. So she sees it at 15. So in order for her to see it at 15, that means we have to have 15 above the 5. That means it must have a total velocity of 20 toward her. Now likewise, for this ball over here, if she's moving at 5, and let's say for the moment the ball 2 isn't moving at all. Let's say it's moving, it's sitting still. The very fact that she's moving at 5 meters per second makes it appear as though this ball is approaching her at 5 meters per second. But she said she actually saw it at 15, so that means it's got to be approaching her at 10 meters per second, so that the combined equal the 15 that she says she saw. So ball 1 would be 20 and ball 2 would be 10.